Right, example 9, solve by factoring. When you notice that you're given something that has 4 terms, sometimes if you look, it might seem like, you know, if I could just like group the first 2 terms and group the last 2 terms, there might be something that's in common here between the first set and the second set. And in this case, it's going to work like that. It doesn't always. Every time you have 4 terms, you can't do this, but sometimes you can. Now, in this problem, first thing you would see is every one of these terms is divisible by 2, right? 2, 6, 6, 18. So divide everything by 2. So this is x to the third minus 6x squared. Oh, sorry, that should have been a 3. Minus 3x plus 9. Okay, and then you group the first 2 terms, x to the third minus 3x squared, and you group the next 2 terms, 3x, and because you just put this in parentheses, that plus 9 becomes a minus 9. Okay, now look at each set of parentheses and see if you could do greatest common factor factoring. Right? What's in common between x to the third and 3x squared? X squared. So that's x squared times x minus 3 minus what's in common between 3x and 9? The 3. So that's x minus 3. And now, because each set of parentheses has x minus 3 in common, right, we can factor one more time. That becomes x squared minus 3 times x minus 3. So sometimes by grouping the first 2 and grouping the last 2, you create a situation where you get the same thing in parentheses there. It won't always work, but at this point in the book, that's all we could really do with this. So the answers here will be x equals 3 and x equals plus or minus the square root of 3.